Sorry. All right, so this is 141. And what I want to do tonight is talk about cryptocurrency. And I'm very happy to have another smart contract language to talk about tonight, but I'm going to start with the original stuff. So we've done this before. You set up a wallet and you get some MetaMask. You set MetaMask in Chrome and you get some Ethereum from one of the faucets. Of course, we're using fake Ethereum on one of the fake test nets, but you have to have some Ethereum, and then you can make a contract. And I want to go through a few of these, showing you how Solidity works to make smart contracts. That's the plan. And then I'm going to talk about Glow. Glow is the new language that I'm pretty sure is intended to run on Cardano, although the version I got here is in fact running on Ethereum, but it's a much better language. And we'll see how it is pretty obvious that Glow will prevent the vulnerabilities that you can exploit in Solidity. Solidity is a miserable language. It's essentially just JavaScript, and it has ridiculous flaws that tend to lead to terrible security problems and have led to millions of dollars being stolen. And Glow is designed to be a more secure language to prevent that, and it looks very nice, although I think all we're looking at now is a pretty early version. We'll see it has some strange limitations. Anyway, let's start by making a Solidity contract, which I should be able to do. I was just working on it earlier, and let me put the Chrome here and just go back to 0 here. Let's see if I can refresh. All right, there we are. So this is pretty much a so you go to this remix.ethereum.org, and this is a graphical environment to practice using Ethereum in, which is really very nice. You don't need anything other than this. And of course, we'll need some tokens on a chain, and you've got that. You set that up before. So first you make a contract, and I'm going to make a faucet. So I right-click on contracts, make a new file, and it's faucet.sol. I see I've already got it here, right? So here's faucet.sol. And one thing that's great about Solidity is you get to specify which version you're using up here. And it's really important because the syntax changes quite a lot from version to version. So whenever you get some script you want to use, you make sure you got the right version up here. And all this will do is give out Ether to anyone who asks. So that's a faucet. And once you put in the contract, now you have to compile it. That's what you've got here. The third icon here will compile it. Click that and then compile. That will convert this Solidity language, which is essentially JavaScript, into assembly language. And you can see the assembly language. Let's see. Yeah, compilation details here. Yep. The compilation details are here. It shows you various things about it. And down here is the actual assembly language in whatever. So it looks a lot like other assembly languages, push and dupe one and revert and so on. But that's the actual stuff that is written onto the blockchain, is the coding for that assembly language. I think it's this runtime bytecode that actually goes. Just this long hexadecimal stuff. Anyway, that's what gets written into a block of data on the blockchain. And now we want to do the fourth icon, 1, 2, 3, 4, deploy and run transactions appears. That's this one. Okay, now we're going to have to connect to a blockchain somewhere, and there are various ways to do it. We're going to use injected Web 3, and that's going to go to the Ropstein network, Ropstein 3. So when we deploy it, it's going to pop up MetaMask, and we're going to need to use a MetaMask contract that has some Ropstein in it, and I've got one. Now this happened to me before. Somehow I managed to get it to go to the right contract. I think reject this one. And yep, there. Close it. Now I'm finally in the right contract. Okay, now I've got this contract has some Ether, which I got from a faucet. And so now I can deploy and hopefully, this is what was happening to me earlier, and I thought I solved it. Now I'm confused. I think I'm going to have to just, It's on ROPS. Somehow I keep ending up with this contract that has nothing in it, and I don't know how to get back to the right contract. Oh, no, that's right. This is okay. I remember this. You can't do it because you have no money. Now I need to put some money in the contract. Okay, this is okay. So what we do is we go find the real contract address. You go to ropstein.etherscan.io, which is here, and you search for the contract address of this contract you've just created, which is in deployed contracts. Okay, let me try this. Deploy, confirm. All right, I seem to be hosed again. I got it working just before we got here. Reject. Okay, here's my account with some money in it. Ropstein Network. Okay. Compile, deploy. Confirm. Okay, now I have a deployed contract. This is what I was looking for. I can copy the faucet here. Okay, I copy the faucet address, and now I can search for it here. Somewhere on this page I can search. Maybe if I trim this junk out. There, now I can search, okay? I'm on the Ropstein network. So here is my contract I've just created, and I have a balance of 0. Now, I can send money to that contract. Okay, click MetaMask and send. Okay, MetaMask. And here's my account with some money. Now I can send to that contract and 0.3 Ether. Okay. All right. Next. And confirm. Okay. And it's pending. And hopefully that will move. Refresh the Etherscan tab. Okay. Good. Here comes a value coming in at 0.3 Ether. Good. Okay. So now I should be able to withdraw from the faucet. On the Remix tab, at the lower left, I go to my faucet, and I guess I'm using this one, not that one. Okay. So I can now withdraw, and I have to put in this large number with quotes. Putting quotes around number is often necessary in this thing. All right, and now I confirm withdraw and confirm. Now some transactions are going by. Good. These are transactions completing on the blockchain. Okay, so that's a start. So now I've made a faucet, and that's just the simplest contract to do. And that was C351. But I want to move on to making a coin with Solidity, which you can do based on the last one. So now we make a file called coin.sol. So I go back to contracts. I made a faucet. Now I'm going to make a coin. All right. And this gets this code. All right, this is JavaScript code to create a coin. So I compile that. All right. And there we are. I get the green check mark. It's succeeded in compiling, I think. Yep, green check marks appear down here. All right. Now I use the JavaScript VM for this one. The fourth icon, 1, 2, 3, 4. Okay, we're going to use the JavaScript VM. All right, that's simulated in the browser. I don't know why there's two London and stuff there that didn't used to be there, but I think they're both fine. And then I can hit the account field here, and that creates several accounts, all of which start with 100 Ether. So we have some money to work with. All right, so now I can deploy the contract, and that should work fine because you see this one just spent some Ether from 100 down to 99.999. That's the gas fee, a little fee to do anything. And here's those transactions going by. So I should now see coin down here, and I do. And if you expand it, there are things you can do with your coin. I can mint and send, and balances and minter are public variables. These are public functions. So I can mint a coin. At the top left, copy my account number, which is here. Copy this 5B, the account number I'm using. Then go to mint. And it has two parameters, receiver and amount. So paste your account number into receiver. And enter an amount of this number. These amounts are all in this GUI, I think, this tiny little, like 10 to the minus 18 Ether. For some reason, they do everything that way, so the numbers all get ridiculously big. And now you do a transaction, and the transaction succeeds. So now, if I go look at my balances on the lower left, go to the gray balances button, and here, okay, I want to put in my account number again, which I can get here, and put it here. And so now I have a balance of 222 times 10 to the 18 or something. So I've now created I've moved some money into there. All right. Now there are two currencies. There's the native currency and there's coins I've defined here, which live on the same blockchain. And that's what you can do. This is what initial coin offerings are in Ethereum. You make a coin and it lives on the blockchain as the others, but it's a different unit of money. Now, if you go buy cryptocurrencies, most of them come with their own blockchain, but these coins are typically living on the Ethereum blockchain. These are the ERC20 tokens. They were all the rage until about 2 years ago. Everybody went to initial coin offerings, then they all seemed to sort of fade away from view. People would do that instead of issuing stock, but somehow it went out of fashion. Now NFTs are in fashion, and this is the world of cryptocurrency. They keep inventing some new complicated thing that people don't understand, and they throw a lot of money in it. After a while, they realize it's not worth anything and abandon it and go on to the next one. All right, and you can send coins around and such, but I think I don't want to bother with this one very much because I want to get to the ones where you're hacking into a contract and exploiting it. And I think probably the most interesting one is this one here, hacking POWH coin. H532. This one here is a real attack that stole $1 million from a bunch of real people. So let me show you how this one looks, and then I can show you the new stuff, which is how you avoid all this. So in Remix, again, the proof of work coin, POWH, is totally online. It's a public thing. It's in GitHub, and here it is, POWH coin. So just copy all this code, and note, it's interesting to look at this code briefly. This code is 132 lines of code, I think. Yep, excuse me, 306 lines of code. Copy that, all pretty much the same thing as JavaScript. This is the code that defines a real distributed application. This one here was created as a joke by 4chan users called Ponzi coin. But it was intended to be a joke, and nobody they thought would put real money in it, but people did put about $1 million of real money in it. And then it turned out, besides being fundamentally poorly designed financially as a joke, it had a bug where you could steal the money, and somebody stole all the money. And because they did it on a public blockchain, every step they did to steal the money was published to the whole world on the blockchain so everybody could totally see how the attack worked and learn from it, and that's what we're going to do. So copy all that code and paste it into powhcoin.sol. So I go here and I make a new contract, powhcoin.sol. Paste in that stuff. All right, so now I've got a copy of that contract. Now I compile it with this one. Compile powhcoin. Okay. And it has done. It is modifying. Okay. Now in the fourth 1, 2, 3, 4, deploy and run transactions. Click the orange deploy button. And we should be using the JavaScript VM, which we are. That's good. Okay. So deploy. Here's Ponzi token. Deploy. All right. And I think it is deployed. Down here is Ponzi token. Now I'm just going to remove some of these other ones we made earlier. Here's a coin in a different project. And now the only deployed contract is Ponzi token, and it's here. So this is more complicated because it's a real investment vehicle that people actually put $1 million in, but it has these various things you can do. All right. For example, you can approve and fund, and so on. All right, so Remix simulates a blockchain we've talked about before. We have a series of accounts up here that start with 100 fake Ether to work with. We've been using the first one, so it spent a tiny amount of Ether to pay the gas for these transactions we've done. And now what we're going to do is put 50 Ether into the contract. So we select the first account here, this one, and copy this number. Okay. In the value line, we put 50 Ether. Now these we are these tiny things. You got to choose Ether if you want to have big money. So that's 50 Ether. Okay. And in the account box, all right, that's good. Now we hit the red fund. What's going to happen is up here you have specified an account to draw from and an amount of money to move. 50 Ether and some gas in the tiny unit gray here. Now if we hit fund here, it will take that money and put it into the contract. So we do that. And see, here's a transaction going by, and the green check mark means it happened. And our account balance has now fallen down to 49.9. So 50 Ether went somewhere, and it went into the Ponzi coin, the Ponzi token transaction. And that's what this says. If you expand this one, it says transact to Ponzi token. To Ponzi token. That's where the money went. Okay. So now we got 50. Okay, now we're going to add another investor. So we're going to go to the second account, which is still full of 100 Ether, and they're going to put 1 Ether into the token. The accounts, they are going to hit fund also. All right. And there's another transaction that succeeds, and now they've fallen to 98.999, so they put 1 Ether in here. So if people are investing in this scheme, now the way this, all right, now we're going to transfer 1 Ether from account 2 to account 3. So first you approve a withdrawal. So we select the third account. Our plan is to approve a withdrawal by account number 3. We take the third account here and copy it. Now we go to this account, number 2, because this is the one that's going to actually pay for the gas. All right, now, in the deploy and run transactions at the bottom, go to approve. Have to be a little careful here. Approve. Here's approve. Okay, good. All right. And paste the copied address into the spender field, okay? And put 1 in the value field. All right. Okay? And so we transact. Now this approves a transaction of 1 from account number 3. Now we check the balance of account number 3. So we go down here and look for blue balance of old, this one here, and paste in that value and call, and its amount is 0 here because we have approved a transaction from this account. We haven't done anything yet, but the point is we've approved a transaction of 1 ether out of this account, but it doesn't contain any ether. So it would seem like we're not going to be able to do that, and this is the problem with it. So here's the hack. To complete a normal transfer, you now transfer funds from some contract into account number 3. But what we do is we transfer ether from account number 2 to the contract, executing as account number 3. This happens because you confuse the code as to which account is actually paying for the gas and which account is actually having the money subtracted from it. Parts of the code assume that those two numbers are the same, but they don't have to be the same. So what we're going to do is we're going to pay for the gas from account number 2, and that's going to fool part of the contract to think it's pulling the funds from account number 2, which has 50 ether, but it's really going to draw the money from account number 3, which is empty. So it's going to subtract coins from an account that has no money. And that will result in stealing all the money. So you go up to the top and make sure that you have account number 2 selected here, the one with 99 ether. That's right. So you copy this account. And now you go down and find the transfer from button, which is up here in the orange, is transfer from, okay. And now you put that in the from field. Okay, now we transfer from this to the fund. Now this fund button is how you invest money in the contract, and that's what you should do. But for some reason, this is a very common mistake, and we're going to talk about this more when we get to the next scripting language. There are multiple ways to do the same thing in this contract, and that is a really bad design decision. And so what happened is this fund button you can use to put money in the contract, but you can also use this transfer button to put money in the contract by putting the contract address in the 2, and you really shouldn't allow 2 different ways to do the same thing because it's likely to lead to disaster, and that's what's going to happen here. So to invest money through the transfer button, I copy this address and put it in the 2 in the transfer from. Now I'm transferring into the contract address, and I put in a value of 1. Okay, now I go to the top and I select the third account. See, what's happened is this is going to take money from account number 2 and invest it in the contract, which would be okay. That account has 50 ether. But what I can do is change this to number 3, and now it's going to draw the gas from that third account. And if I have done it all right, and now this transaction should perform the attack. I do this transaction, it succeeds and gives me a green check mark. Now I go down to balance of old and call this. That's what happens. This worked. Now what it did was it subtracted 1 from an empty account, and because this language is incredibly stupid, you can subtract from an account with 0 and it will roll over and turn into the largest possible positive number. So now suddenly account number 3 has 2 to the 255 or some coins, some ridiculous, incredibly, essentially infinite number of coins. And so I just stole all the money in the whole system. It is, and the reason it happens is because this language is just pretty sloppy and the developer has to think of everything. So here's the vulnerability. Here's the function that does transfer from. See, it has an address from and an address to. And so first it makes sure that the allowance you have is less than or equal to the value, which is the allowed value, right? But then transfer tokens, this checks to make sure that the from address is sufficient, the balance in the from account is sufficient for the withdrawal. But when you actually do the cell, which is used, it draws that from the message sender. That's the problem. There are just too many addresses here. And as you notice, when I was doing it, it was pretty easy to get confused about which address you're copying, and the developer got confused. Here they took the from address, which is the address that we're drawing the money from, but here they verified the value on the sender address. And the sender address is the address that's paying for the gas fee, that tiny little gas fee. And it's not necessarily equal to the from address, although normally it would be. So that mistake made it possible to trick it into sucking money out of an empty account. There are just so many things wrong here, it's hard to summarize them. I mean, you shouldn't have multiple ways to do the same thing. You shouldn't have all these multiple addresses that are often the same but aren't really. You should not be able to draw any money from an account that's at zero. There should be a variable type that only holds positive numbers, and you can't go below zero, obviously, if you're handling money. Anyway, that's the big proof of work coin hack. And so that's what I wanted to show you, is how dangerous these things are, because now I can compare it to Glow, and we can see why Glow is so much better. So I'm going to stop this recording and make another one.